So hello everyone, my name is Sebastian. You can find me on Twitter on the name thefubi or on Drupal.org as just Fubi. This talk is about GraphQL, a querying syntax developed by Facebook, along with many other open source contributions that Facebook has pushed on GitHub in the past year, including React, Relay, and well, just an enormous amount of code that tries to make developing front-end applications a better experience. Oh, sorry. So before we begin, I want to share with you a little story about how I got to know GraphQL and how I started adoring GraphQL as my go-to solution and replacement for standard REST. About a year ago, I was working at my previous employer, and we were working on a very complex client-side application. It was not a typical website, more of an intranet application for libraries and institutions that wanted to digitize a lot of their physical books and other assets like maps and drawings, and wanted to make them accessible through the web. And because of the nature of the application being very interactive and also very data intensive, because all of the books that you scanned were also decorated with information about the text that was contained in there, and you could search the text and so on. There was a massive amount of data flowing back and forth between the front end and the back end. And we started working on this with a Drupal backend and a simple Drupal frontend using some widgets that were written in JavaScript, and they were interacting with the backend using traditional REST and different versions of different RESTful modules provided by the Drupal contrib space. And as the application grew and our frontend was becoming more complex, we started running into a lot of different issues with the traditional REST approach. And I want to show a couple of those. It is not limited to those, because we are seriously struggling with the entire approach. And but one of the most fundamental problems was the performance of the application. And most of that stemmed from the fact that in order to fetch hierarchical data, we needed to run multiple round trips, hitting the server more and more often based on the structure of the data that we required. So to give you a better example for that, for example, if you had a user object, because the user was authenticated in the site, and based on the user object, you had different permissions, different roles, etc., that we wanted to access in the front end. We had to first load the user object, then we had to fetch the roles, then we had to fetch other permissions, and so on. And this was all by using standard REST modules. But in order to solve that, we started writing our own custom resources with custom controllers, custom routes that would simply fetch the data in a structure that was more fitting to our use case. So also, we ran into a lot of overfetching problems. As I said, the data requirements were really huge, so the amount of data that was transferred back and forth was increasing in size, and so we ended up sometimes with payloads for our requests which were exceeding the 1 megabyte barrier. And another problem was because the application was also supporting native devices, and like we had native apps for Android and iOS, and those were all functioning slightly different. And so we had different versions of the API that we had to maintain in order to prevent breaking changes when we wanted to change a particular resource for just one of the applications. And that came with a lot of complexity. So because we had these different versions, every time we wanted to change something on one of the API, we had to also consider the other versions of our application. And it was just increasingly becoming impossible to maintain all of these different versions of our API. Right. So let's go into detail, or actually, first, before we continue, this is not a bash on REST. REST is still fine, and there are use cases for it, and I still love REST, and we are still using REST for other scenarios. But if we have a very complex client-side application, or even other stuff that is really, really of a dynamic nature and requires structural data, I think REST is not the right approach, and we have better solution at this point. And today we are going to talk about GraphQL, which I think is a tremendous effort by Facebook and solves a lot of these issues. So yeah, as we already talked about, multiple round trips. When you fetch complex data and the data is of a relational data structure and just fundamentally hierarchical, you end up running multiple round trips if you want to follow the traditional REST principles. So what happens is in your front end, when you look at the UI and data flows into your application following these round trips, it looks like some sort of stuttering if your performance is just really bad, because first you render pieces of information here, then as a result of the first response from the server you fetch another set of data, and then it just looks like a stop and go car driving. Overfetching, we also talked about that. Fetching too much data and basically just increasing the size of the payload without any justification because you don't really need that information. And it looks like that, just someone puking in your face. And yeah, versioning, complexity really increases as soon as you start versioning your APIs. And with GraphQL, we have found a solution for actually not versioning our API at all, because we have built-in support for deprecating functionality, and if some model in the backend changes, we don't have to necessarily, or that doesn't have to necessarily result in a changed API response. Instead, you would basically create backwards compatibility layers in your API without having to version that, and we'll look at that later as well. So as a result of these problems, as I described, we started using custom resources, custom controllers, custom menu paths, and responding to those requests with very specialized response structures. And because of our different applications, iOS, Android, etc., we had to create different versions of those as well. And it just increased the complexity and made the app nightmare to maintain. So usually your API is composed of a different range of these solutions. So some of your resources might be fully RESTful, some aren't, and at the end you have this mishmash of different interpretations of REST. And that's also a problem, because today we actually call everything REST. As long as it's an HTTP API, people call it REST, and it doesn't have to follow any principles. Just the other day on Twitter, I had a conversation with Tim Plunkett and some other people, I think, and we were like looking at an API which named itself RESTful, but it wasn't. And so no one really knows what REST is, and there's no formal specification that actually somehow limits that wording to a specific pattern. There's just very, very informal specifications, and it allows it has a lot of room for interpretation. And fundamentally, REST is what you make it because of that. So you write your API, you call it REST, it's REST. Right. And I really like this comment from Nick Schrock. He's one of the developers behind GraphQL. And he said that we as developers don't really think of our data in terms of the database or so. We think about it as a graph, right? So you have a user and there's related data like friends or so on, and that's really how we think of our data. We don't think of our data as URLs that we call, right? So you don't think of it like, okay, first fetch the user object, and then because the user has these IDs that are related to it, like friend IDs, we fetch that again. You think about it as a whole structure, one single piece of information, and you want to fetch specific parts from that. And that's how your data graph really looks. By the way, you will see a couple of these slides. They are code cartoons by Lynn Clark. You know Lynn Clark, she used to be a very prolific member of our community. She's moved on to Node right now, but she is producing these Node code cartoons, and if you're interested in React and Relay and GraphQL, you should check them out. There's a couple of them on her blog. So let's talk about GraphQL. What is GraphQL? GraphQL is a query language designed to build client applications by providing an intuitive and flexible syntax and system for describing the data requirements and interactions. What is important is GraphQL is not a language for a graph database. Seeing that actually makes you question, why did they name it GraphQL? It doesn't make any sense. And I really don't know why they named it GraphQL. Maybe because they built another tool on top of it, which is called GraphQL, GraphQL, and it really makes for a nice name. But Other than that, it is not a query language for a graph database. Because what is it? It is a database or a storage agnostic syntax that allows you to execute application code on the server to fetch data or mutate data based on arguments and the fields that you requested. So it is completely agnostic of the storage layer because it is actually function calls over HTTP. And if you have used .NET before, and if you're familiar with .NET, you might have heard about remote function calls or remote objects, because there's this notion of API interaction where you basically publish an object to the client, and the client then gets to execute the actual methods, which are part of the server-side API. And this is really how GraphQL works. And this is how it looks. So if you take a closer look, you will notice that it's very similar to JSON, except that there's no values. So you just get the field names, the property names. And this is also intentional because the response is in JSON, and it allows you to write the query in the same way that it is later on returned by the server. So what GraphQL basically does, it takes the query and fills in the values on the server, right? And right now it is not very, very obvious, but with this, it gets much more obvious. So it's actually function calls, and you have arguments. So user ID 123 is not actually simply loading an SQL query on the server where it fetches from the user table using that ID, but instead, it calls a function on the server which hits the entity storage layer, if you're talking about Drupal here, and loads that specific entity simply using the entity API. And name, because it is nested in that hierarchy, receives that entity object and picks the name field from the full entity object and returns that. And then this is basically the output for that. And we have support, as I said, for hierarchical data. So what if I have objects which are nested in the structure? So for example, an entity reference that is named company, and it's actually a separate entity on our Drupal side, and it also has properties. So instead of fetching the company ID and then doing another round trip to the server for returning the company information, you just fetch in a single query and specify, okay, from me, which is user ID 123 or something, I want to have the name and the company, and because the company is an object itself, which describes another field or another set of fields, we can say, okay, from that company object, I want to have the name and the website property. And those, if we're talking about Drupal again, would simply be entity fields or entity properties. We can do a little bit more than that. So not only do the root calls support arguments, but also every other field that is nested, every other subselection. This is called a subselection, right? So this is the root call. These are the subselections. Every other field has the ability to provide a range of arguments that you can use to modify the response. So we can load like a field, an image field, and say, okay, I want to have a specific size, or I wanted to use a specific image style, and then you can use the properties, the width, height, or URL, anything else to fetch specific information for that particular function call. But what if I wanted to fetch 2 profile pictures? Well, in this case, you can use aliasing to say, okay, small is now the name of the field in the response, and the second one would be large. But we are using the same function, the same field from the schema that is provided to return different information with different arguments. There's also the ability to fetch lists of things. So let's assume that we have another, that on the user object we have an entity reference that shows a list of articles. Then you can basically just get that as a list and iterate over that in your front end.
Can you go back one slide?
Yes.
Thank you.
Are you going to tweet that? And it goes, you can go even deeper than that. So you have an entity reference for articles, then you fetch the title for each of those, and another list, which is the comments on each of those articles. And for those, you can again fetch properties, the author again, the name of the author, the label of the comment, whatever. And it also supports pagination. We are going to talk about that, and I'll show some examples of how that actually works with GraphQL Relay. Pagination is not 100% supported in the Drupal module yet, but I will talk about the Drupal module later. So again, a code cartoon. And I think it becomes now clear how we are solving these problems of over and under fetching. So previously, in a standard REST approach, the server basically dictates what it gives you. So you're requesting a resource that has been predefined, and the server answers with a given set of response data. And you, as the consumer of the application, you're basically powerless. You just receive the data that the server wants you to get. And then you might have an issue where the information that you get back from the server is simply not enough. So that's called underfetching. Or you're getting data that you don't even need, therefore increasing the size of the payload without any reason. That would be on the right side. And we're changing that relationship by saying, okay, we are empowering the client. We're telling the client now gets the ability to say, okay, I want these specific fields based on the things that the server can provide. And then we really just get that data, nothing else. And I think the most fundamental thing here is that we are actually changing the relationship, the traditional relationship that between the client and the server, and where we are empowering the client so that now the server does not publish data initially, it just publishes the possibilities, the schema of data, the hierarchy of the data that the server can potentially provide, and the client then says, okay, I need that particular subset of that information. So really changing that responsibility. And I think it also makes sense because the server doesn't know what data you require on your front end, especially if you have multiple different applications on your front end. Okay, so how does that work? At the core of GraphQL, or at the core of your GraphQL implementation of your server that supports GraphQL, you have a schema. And a schema is simply a set of type definitions, hierarchical type definitions that are interpreted by GraphQL and combined into a single schema that can be consumed and interpreted on the client side as well. So when you these examples are just pseudocode, right? So don't interpret too much in that. It's just pseudocode to make it easier readable. When you set up a GraphQL server, what you have to do is you have to generate or statically define a schema by providing fields that act as so-called root calls, entry points to your initial query. So for example, user, it would be a simple function call that you also provide and decorate with a title, a description, etc. And this would be basically how it looks. So you specify, okay, I have a user field and it has these particular arguments that you can give to the function, which are then taken into consideration when loading the data. The type system supports a whole range of different types. So you can provide object definitions, you can provide interface definitions, you can provide enums, you can provide just simple integers or string or Scala values, and basically it is a whole thought-out system for you to be able to build a whole range of tooling on top of the GraphQL server on the client side, and that's also how the graphical interface that some of you have now open is working. So how do these things work on the client? Well, basically, once you have defined the GraphQL schema on the server, it also generates a couple of magic schema properties for you that you can use to read and parse that schema on the client side. So you can basically tell the server, hey, give me all of the information that you can potentially provide me with. And then you can interpret that data and, for example, build an IDE on top of it that has autocompletion for your schema. It gives you the ability to generate documentation for your schema, and it all comes natural with the way you're describing your schema on the server. You don't need to do any extra work for it. It's just data. It's just extra GraphQL fields that are generated for you based on your existing schema. Right. So building a GraphQL server is exceptionally simple. It's actually one of the simplest things that you can think of when you are building an API compared to setting up a proper REST server. It's much easier to work and create a GraphQL implementation because at the end it's just function calls. So what you need to do is, first of all, you will have a database or maybe other external services that you want to communicate with. And then you can write application code, which basically serves as a middleware between those data storages and the GraphQL specification. So in this case, for example, it would be the entity API or some other code that loads stuff. Like an SDK for Twitter API or Facebook API. And then you create the GraphQL schema, which simply provides you with information about those available functions, and you link names and types and descriptions to these functions. This is basically how that would look. So you say, okay, I have a type user, and the type user has a name property, and the name property is basically accessible through that function. The function gets the user object as an argument, and you return the name field from that argument that you get into the function. You can also provide additional arguments. If you want to load articles, you might have, like you want to specify how you want to sort the list of articles, or you might want to supply a set of filters, like only articles that have been published in the last 2 weeks. Then you'd give that as arguments, or provide those as arguments to your schema, and the storage loader would then be able to react to that and filter accordingly, craft the query accordingly. So let's look at a short demo to make a little bit more sense out of this whole thing. Right, so if you have your laptop, you can open this yourself and play around with it as well. This is basically the go-to demo application if you want to try out GraphQL. It is the graphical interface, one of the toolings that I already mentioned that you can build on top of GraphQL because of the nice schema introspection. And this is, in this case, it is the Star Wars API. It allows us to fetch information about Star Wars movies, species, planets, etc. And this is all written in Node.js, and there's also a GitHub repository for it. So if you want to try out and modify that a little bit, you can also do that. So as I said, we have now a schema. The schema is accessible through the documentation on the right-hand side. So as you can see, this is basically auto-generated documentation for the schema. But you also get auto-completion or type aheads for your queries by simply hitting Control space. So if we wanted to render a list of films and fetch the title for each of the films, this would be the most simple query that you can think of. But you can also specify other stuff that you want to render. And it really only gives you that information, nothing else. We can also follow references. So we can say, okay, give me all of the species that were present in one of the movies. And say, okay, only give me the name for each of the species. This is going to take a little bit longer because there's quite a few of them. And as you can see, okay, so we have the film The Empire Strikes Back. This is the director. And these are the species. We can provide arguments and say, okay, only give me the first 2 of those movies. And also, only give me the first 2 species per movie. We can say, okay, give me the ID, the unique ID of that single entry. And we can even follow further references. And again, render like all of the films that this specific species appeared in. So now we have the movie, the species, and all of the other movies the species appeared in. Are there any questions for that? Good. So you can try that out on your own laptop and play around with it a little bit more. You get auto-completion for that, so it should be very simple to play around with that. In addition to loading lists, you can obviously also say, I want to just load a specific entry. So just load the second film, and for that, the producers. And it's all very natural. So if I know that this film is called The Empire Strikes Back, and I maybe want to fetch just 2 films, we are now in the situation that we can't, as you can see, we get an error, because we can't use film twice here, right? So what we do is, we alias that. And then this is the response. So it really lets you craft the query on the client side. And here you can see that the client is now responsible for specifying what it wants and how it should look like, how it should be structured.
Can I make you a short question?
Yes.
Do it have any kind of validation if, for example, the ID is not correct or is not the correct type?
Yeah. So validation is mostly relevant for mutations or for write operations, but you're talking about validating on the client side if the ID is even available on the server. Well, if you are querying for a film which is not available, it simply doesn't return anything. So now you can see my data is null, but it says also no entry, right? But it still tries to satisfy the response and tries to follow the code. So this is actually in a normal GraphQL implementation, you would still show the result for the second query. But since this is actually just a dummy implementation, it stops at the first error that it encounters. But there's also, I think your question also extends to how does it work with access, with permissions. Usually when you have a long query and you want to account for permissions, you would simply not return the values that the user doesn't have access for, but still resolve the rest of the query so that you get the data that you do have access for. But that's an implementation detail. GraphQL does not dictate what you should do in that case, so it's up to you really. Okay, let's go back to the slides. This is just a very basic syntax, right? We are going to look at more complex examples afterwards. So there's more. GraphQL is not limited to simple fetch operations. You can have mutations, so you can have write operations. As part of the write operations, you can do a subsequent fetch. So for example, if you had a write operation saying, okay, create comment, and you want to know the ID of the comment that has been created as part of that operation, you can say, create a comment, and as part of the return value of the post request, I want to have this information. So you can say, okay, create a comment, and then give me the new ID, or give me some computed value that has been computed on the server and that I can't know on the client side yet, just naturally. So that's also possible. You get fragments. Fragments is a type of mixins. We'll look at the syntax for that, so that you can reuse bits and pieces of your queries in multiple ways. You get conditionals, so you can say, okay, I have this predefined query, but I don't only want to include this specific field if a certain condition is true. For example, if the user has a given permission. Otherwise, don't even bother going into any of these fields, although some parts of that information would potentially be accessible by the user anyways. You get pagination. This is really, really interesting and also very powerful. The implementation for pagination in the GraphQL spec is tremendously well executed. We will look at that example for that as well. And you get cursors. Cursors allow you to jump back and forth in pages based on information or based on a specific anchor in the list. So let's say you have a list of 10 articles and you want to fetch the first 10, and then you don't have like a specific page 1, page 2, page 3 thingy. Instead, you want to say, okay, next time give me the next 5 starting at the last item that has been fetched. So you get for each item in the list, you get a cursor identifying the position of that element in the list, and then you can continue fetching the additional entries. But we also look at that. And something that is extremely cool, subscriptions, WebSocket subscriptions. So GraphQL allows you if you have a backend that is capable of WebSockets, to send queries the same way as we just did, but annotating them as a subscription, which then opens the WebSocket connection and informs you about the changes and pushes the changes to the client whenever something happens on the server that mutates the data that you have previously fetched. Right, so pagination. Going back to the example with the films, you can fetch information about available entries on the database. You can fetch information about whether or not there is another page given your current filtering criteria, and you get information about the starting entity and the last entity in your data set. Also, you can use that. You can then use arguments for the root query entry to say, okay, just give me the first two entries, give me the ID and the title for each of those, and render the cursor for each of those items, which we can then use for the pagination. And this is how that will look, basically. So in the next query, you can then say, okay, now give me the next two following the last item that I have previously fetched. Then also, we have universal unique identifiers, which is not to be confused with the UUID that we have in Drupal, for example. It's not a predefined value with a couple of integer and string values separated by dashes, but instead it is just a base 64 encoded string, which is made up of the type of the object, the type definition that we have for the GraphQL object, and the value of the ID that enables us to load the object. And this is really handy because GraphQL, or rather the relay dialect of GraphQL, comes with the assumption that you can load an arbitrary object through a generic entry point called node. Don't confuse that with Drupal nodes. This is just the entry point and how it is called in the relay spec. You can pass it an ID, which is the base 64 encoded string, and get in return the object. But because this is so generic, the schema does not know which object it is going to return. However, it also allows you to fetch a specific subproperty called type name, which contains the name of the type that makes the object, which is the ID that you provided here. And then you get fragments. And then fragments allow you to say, okay, if the object that has been returned is a film, give me these properties. So let's look at that. So we fetch the film with ID 1, the first film in the set, and we want the ID for that. Yep. So this is now the unique ID. And then we can use the node entry point here to load that object and say, I want the ID and the type name. Because this is just the interface node, it doesn't have any extra information. I can't fetch any extra fields unless I say and build in the switch, if this object is of type film, give me the title. And I can then reuse that in a generic fashion and say, okay, if this is a planet, give me the name. But because it's not a planet, it doesn't go in there. So let's fetch a planet and see what happens. Let's get the ID. So if I now use this ID instead, it will go into the planet fragment and fetch that instead. Okay. We can also make these fragments reusable and define them on the outside. So we can say fragment my planet fragment on planet. This is how you can make your query usable. Let's remove that stuff. And now you can reuse that same fragment to load the same stuff for multiple subsequent queries, because that's also the magic. You can use many different queries, many different root calls in the same set of queries. All right. Another thing that is also really nice is it allows variables to be used. So for example, if you had a query that you wanted to use in many different places in your application, sometimes you would obviously want to provide an argument, a variable. So you'd say, okay, this query supports the argument ID, which is of type ID. And then you can specify that as a simple get parameter to your query and say, okay, ID is this value, and so it executes the query. This is also really nice because what you can do with GraphQL, and Facebook actually does that. Instead of exposing the entire GraphQL API and the entire GraphQL schema, you can actually, if you have a JavaScript application, for example, build or add a build step to your toolchain, which extracts all of the GraphQL query syntax and puts it into your PHP backend, generating routes there, which simply are a hashed path, and then execute the query on the server side, but simply by basically calling a plain route without any GraphQL query anymore, and just pass the variables to that route. So you hash the query, generate a route in Drupal for that, and pass the variables, and you'll get the same response. That way, you can lock down the GraphQL API once you're once you're finished with your application, and you can therefore obfuscate the API again and just expose the resources in a REST fashion as you would do without GraphQL. Right. So we don't have much time left. Since there is no VGA port on this one, I can't really show you a Drupal demo yet. But I will go and hold the buff later on. I'll try to communicate it on Twitter, and then we can look at how the Drupal module currently works. We'll also talk about the future of the Drupal module and when it's going to be released. Spoiler, next Wednesday. The module is not going to support mutations yet, but it is going to support relay. It is going to support all content entity types and their fields. It will not support config entities at this point because the entire thing is based on type data, and it's currently quite painful to make that work with config entities. It supports views and entity query for fetching lists of things. It will support the relay syntax, as I said, so you'll get pagination, you'll get cursors, and so on. And yeah, it automatically generates the schema, so there's no manual coding involved. You install the module, and you have support for all content entity types out of the box, and all of the fields as well. You can follow entity references to fetch related data, and you can also make reverse entity lookups possible. So, for example, if you have a user object, and you have an article if you have a user object, user entity, and the node entity has a reference to the user, then you can also follow the reference in reverse and say, okay, give me all nodes that currently reference a particular user. Right, so yeah, next Wednesday. And also, if you want to play with GraphQL and Relay on top of React, I published a Drupal decoupled app repository on GitHub just recently that works with Relay and React out of the box, has server-side rendering, service workers, lazy loading for routes, etc., all built in. And once the module is released, I'm going to switch that to a Drupal backend and make it possible for you to use that as a starting point for your fully decoupled apps with Relay. Couple of resources. the slides are going to be published, so you'll have the chance to copying them there. And to not eat up any more time, let's go to questions. We just have 5 minutes, sorry. Are there any questions? Yes.
Now that there is this issue in Drupal core about components, does it make sense to have like this query language available to that kind of project, like not being client side, but having it within like the components template in a way of in a like more descriptive way to get the data that you want from Drupal?
Yeah. So the question is, can you somehow make that work on the backend in Drupal as well, right? So yes, you can obviously execute queries on the backend too. You can just execute using Guzzle and send the post request to another Drupal instance, for example, for fetching or like migrating data between those two Drupal instances. There's already been like very interesting ideas about making templates, Twig templates work with Twig. So instead of specifying preprocessed functions and pushing data to the templates, why don't we specify in Twig data requirements for each specific template, which are then accumulated in a single query, and then at the end of the execution process of your Drupal website, you are basically pulling all of the data that all of the templates together have required and just push that data into the templates instead. So have the same approach that Relay does, but just on the back end. Yeah, that's actually a really cool idea. I like that idea, but it's kind of scary at this point. So it's probably something for a very, very far future version of Drupal. There has also been the question of like building views on top of the GraphQL schema. Also a really cool idea. I like that. Also really scary. So maybe also something for the very far future.
Why do you find it scary?
Because it involves a lot of work.
Because the implementation, like there's a lot of magic or a lot of like middle steps in the client logic.
Yeah. So it's just an enormous effort. Any other questions?
So are you saying
Microphone.
So, are you saying ditch your REST APIs and use GraphQL instead?
REST API should use GraphQL instead.
No, I'm saying, are you actually saying stop using REST API, RESTful?
Depends.
Okay.
If you want to like set up a website as a generic REST resource, which you don't have like a specific client-side application for, but you just want to make it publicly available on the web, use REST. It's just the standard that everyone has currently agreed upon. But if you have an application which conforms to the requirements that I had in my project last year, then yes, GraphQL is definitely much more powerful than REST. But as I said, REST isn't dead just because of GraphQL. It's still a valid approach. Depends on your use case. Other questions? Time is out anyways, I guess. Oh yeah, one more question.
Who's your favorite Star Wars droid? So you
That's really awkward now.
so
So
you
I'm
basically
using
don't
that
know
Star
what you
Wars
were
API.
talking about.
I'm not a Star Wars fan. I don't watch Star Wars. So I wouldn't know.
Thanks for the effort.
Yeah. Okay. Thanks for your yes.
Is there anyone else using GraphQL with Drupal already?
With Drupal, not that I know of. I hope that changes though once we have the module released. So the question was, is there anyone else using GraphQL with Drupal? I don't know of anyone currently, but I hope that changes once we have the module released. And yeah, if you have any questions, you can also ping me later, and I'll host above where I'll show the module. I'll post that on Twitter. Good, thanks.